Hello everyone. Today we are going to talk about density. Density is a word that you are going to hear throughout this year and you've probably heard in your previous science courses. So to get you started off, let's go ahead and think about what density means to you. In everyday language, you might hear the word dense and you might think it means like a lot of information in one section. We sometimes might call people dense. That means that, it's difficult to get information through their thick head. But in chemistry, we use density as a means of comparison for objects. You're probably familiar with the equation D equals M over V. And D stands for density, M stands for mass, and V stands for volume. So this is what we're going to be looking at today. So before we get into the information, I always like to give you guys the objectives, like what should you be paying attention to today. So today students will be able to explain what density describes, define and identify the measurements needed to calculate density, successfully calculate volume and density, and describe on the molecular level why materials are more dense than others. So you've probably seen these first three before. Number 4 is probably the new one here for chemistry, because remember, we're looking at the composition and structure of atoms and molecules. So I really want you to pay attention to that. Okay, so as we go through this, I want you to start thinking about if we have the following samples of copper and aluminum, if they have the same length, width, and height, that means they have the same volume, but why do they have different densities? So as we go through this, please think about that. So a quick review of density. Again, we have this density is mass per volume. And so, again, here's our equation, D equals M over V. Mass is the amount of matter in an object. We sometimes use that interchangeably with weight, but remember that weight is affected by gravity, so mass is just how much stuff are you made up of. And then volume is the amount of space an object occupies, like how much space does it take up. So the question here is, so if both cubes have the same volume but different densities, what must be true about each cube? So let's look at this again. So if both cubes have the same volume, okay, so this is equal. I should put a little equal sign there. But this is different. What about this? Which one of these variables is going to have to be changed? So I'm hoping you're saying that, well, each block must have a different mass. Okay, so the masses are different. So there we go. It says, I hope you said mass. So how can the mass of two equally sized objects be different? Well, the mass of the material that each is made up of is going to be different. So if I had a cube meter of lead and a cubed meter of feathers, these are my really badly drawn feathers in here, of course, they're going to have different densities because I have all my little lead molecules in here. They're very close together. It's very solid. But over here, look, there's a lot, but over here, there's a lot of space between these feathers. So this is obviously going to be the more dense one because it's more massive, even though it has the same volume. So the mass of the atoms can also be heavier. Their size and how they're arranged can also determine the substance's density.